The pressure by water vapors, what will be the exerted, that will be called as aqueous tension, that overall pressure. In the Zedols method, the organic compound is strongly heated with concentrated sulfuric acid, that is nothing but H2SO4. You should not forget the two various kinds of methods. One is Dumas method and Zedols method for the estimation of nitrogen. The acid formed is then treated with barium chloride. Whatever the acid will be formed, that will be treated with barium chloride. That time barium sulfate will form as a white precipitate. Hello everyone, this is Harshita Bhavasar from Vidhyaashram, PU College, Temple of Excellence. Today we are starting up the session 8 from the chapter Organic Chemistry, some basic principles and techniques. In the last class, we have discussed about qualitative analysis of organic compound and some of the quantitative analysis. Okay. In that quantitative analysis, in the last session, we have done the carbon and hydrogen by Liebig's method. So, in this session, we will continue that quantitative analysis. Within that, estimation of nitrogen, estimation of halogen, sulfur and phosphorus. So, first one, we will see estimation of nitrogen by Dumas method. What is that method's principle is? In this method, the given organic compound is heated with cupric oxide in CO2, that is carbon dioxide atmosphere, when nitrogen gas and oxides of nitrogen are formed. The oxides of nitrogen gases are converted to nitrogen by passing over heated copper gauze. The gases formed are collected over potassium hydroxide solution, and from the volume of nitrogen gas obtained, the percentage of nitrogen in the given organic compound is determined. This is the overall principle where the organic compound is heated with cupric oxide, that is CuO, in the presence of carbon dioxide, that is atmospheric carbon dioxide, and when nitrogen gas and oxides of nitrogen gases are formed. After that, treating with cupric oxide and carbon dioxide in atmospheric carbon dioxide, the nitrogen gas and oxides of nitrogen will be formed. So, the oxides of nitrogen gases will be converted to nitrogen. Whatever the oxides of nitrogen will be formed by the cupric oxide treating with organic compound will be converted into nitrogen by passing over a heat of copper gauze. The gases formed are collected over potassium hydroxide. Whatever, after heating the gas over the copper gauze, the gas will be collected by the potassium hydroxide, that is KOH. And from the volume of nitrogen gas obtained, whatever the nitrogen gas is obtained from this method, within that the percentage of nitrogen will be estimated. Okay. See here, this is overall the apparatus. This is nitrometer. Here the nitrogen gas will be filled, and here the carbon dioxide, the atmospheric carbon dioxide will be given inside the furnace. See, copper oxide gas. This is cupric oxide plus organic compound is getting mixed here, and this is coarse copper oxide, and this is reduced copper gauze. After that, the gas will be heated over copper gauze, right? That is here. And the gases which are produced over that heated copper gauze will be present here. By this nitrometer, the nitrogen will be estimated. Okay. This is the principle. And what is the procedure? A known mass of nitrogenous organic compound is heated in the combustion tube containing copper oxide. In that, carbon dioxide is passed through the tube to remove the atmospheric air. The organic compound decomposes to give nitrogen gas along with carbon dioxide, water and traces of oxides of nitrogen. The oxides of nitrogen are converted to nitrogen gas by passing the gases over heated copper gauze. You have seen already apparatus now. What they are doing, the same thing of principle what we have already discussed. A known mass of organic compound they have taken, the nitrogenous organic compound. Then it has been treated with copper oxide or cupric oxide they have treated. In the presence of carbon dioxide, they have given out the carbon dioxide to remove the atmospheric air. and the organic compound decomposes into the oxides of nitrogen with carbon dioxide, water and traces of oxides of nitrogen. The oxides of nitrogen will be converted into nitrogen when it has been passed over a copper gauze. Then the remaining nitrogen gas will be estimated in the nitrometer. Okay. See here, organic compound, this is nitrogenous organic compound and treated with cupric oxide. These are all the estimation of how much the molecules have been taken. This is carbon dioxide. Here water will be released and copper will be reduced here. Okay. And oxides of nitrogen will be passed over heated copper gauze and remaining nitrogen and copper oxide will be the product. This is overall procedure. And the gaseous mixture is collected over aqueous potassium hydroxide solution. Carbon dioxide is absorbed by potassium hydroxide solution and nitrogen gas is collected in the gas jar. From the volume of nitrogen gas obtained, the percentage of nitrogen is calculated as follows. See, we got nitrogen gas. That gaseous mixture is collected over the aqueous potassium hydroxide, that is aqueous KOH. Okay. That is the usage of treating with potassium hydroxide. It will remove the carbon dioxide which has been treated inside that combustion tube. And the nitrogen gas is collected in the gas jar. Whatever the nitrometer gas jar was present here in right side, within that it will be present. From the volume of nitrogen gas what they have took inside that, from that the percentage of nitrogen was calculated. See, this is the calculation part. Mass of organic compound taken is mg. Volume of nitrogen gas formed, that is Vml, volume ml. Room temperature in Kelvin. The pressure of gas collected with respect to mercury they have taken mm. Aqueous tension of room temperature is Fmm of mercury. Volume of nitrogen gas at standard temperature and pressure, that is STP, P minus F into V by T into 273 by 760 equals V1 ml. 273 is Kelvin value, you know that. 22,400 ml of nitrogen gas at STP. This is the standard value of STP equals to 28 gram. N2, 14 2s are 28. The molecular weight V1 ml of nitrogen gas at STP, how much they are asking. So that will be X, 28 into V1 by 22,400. So how you can calculate into percentage? Percentage of nitrogen X into 100 by M. Okay. What is aqueous tension? Pressure exerted by water vapors in the gas collected. And the pressure of dry nitrogen gas is pressure inside the gas jar minus aqueous tension. That water vapors, the pressure by water vapors, what will be the exerted, that will be called as aqueous tension, that overall pressure. And the pressure of dry nitrogen gas means the pressure inside the gas jar, it will minus the aqueous tension, because that aqueous tension was belonging to the pressure was exerted by water vapors. Here they need only dry nitrogen gas, that's why they will subtract it over. Now we will see the problem. In Dumas method, 0.30 gram of an organic compound gave 32 ml of nitrogen gas at 27 degrees Celsius and 750 mm of pressure. Calculate the percentage of nitrogen. Given aqueous tension is at 27 degrees Celsius 20 mm. They have given mass of organic compound 0.30 gram, volume of nitrogen gas formed 32 ml, aqueous tension 20 mm of mercury, temperature 27 plus 273. Okay, this is in the Celsius. They are converting into Kelvin. You will get 300 Kelvin. Pressure of gas collected 750 mm of mercury. These are the given data. And the volume of nitrogen gas at STP. This is 750 minus 20 into 32 divided by 300 into 273 by 760. P minus F into V they have given, right? Overall, after calculation, 27.97 ml will be given. So, mass of nitrogen in the given organic compound 28 into V1 by 22,400. How much you will get? Here V1 you have got here, that should be substituted over here. You will get 0.0349. How you will find out the percentage? Whatever you got, that mass divided by given mass into 100. you got this mass and already given mass here into 100, 11.63% of nitrogen was present in that compound. This is about the overall estimation of nitrogen by due mass method. And still the estimation of nitrogen will be done by other methods also. That is, one another is Zedoll's method. What is that Zedoll's method's principle is, the organic compound is strongly heated with concentrated sulfuric acid. The nitrogen in the compound is converted into ammonium sulfate. This solution is then heated with excess of sodium hydroxide solution. Ammonia is liberated, which is absorbed in a known excess volume of standard acid. The volume of unused acid is determined by titrating the solution against a standard alkali. This gives the amount of ammonia absorbed. From this, the percentage of nitrogen in the compound is determined. Okay, what they are telling means, in the Zedoll's method, the organic compound is strongly heated with concentrated sulfuric acid, that is nothing but H2SO4. At that time, the nitrogen in the compound is converted into ammonium sulfate, because H2SO4 plus nitrogen will be converted into ammonium sulfate. And this solution was treated with excess of sodium hydroxide, which is a alkali. Okay. And that time ammonia will be liberated, that is NH3 will be liberated, which is absorbed in a known excess volume of standard acid. Ammonia was recognized and ammonia was liberated. Whatever the ammonia was absorbed, it should be in a known volume. Okay. And whatever the volume of acid was unused, that was treated by an alkali or titrated by alkali, because in the titration part, how much acid is used when it has been titrated, it will be accurately known. That's why they have titrating against the standard alkali. This gives the amount of ammonia absorbed. How much ammonia has been absorbed, that was calculated by this titration part. When the ammonia has known in accurate volume, by that ammonia itself, the nitrogen has been estimated or calculated. That is the principle of Zedoll's method. See here, organic compound with sulfuric acid, it will give ammonium sulfate. This ammonium sulfate was treated with sodium hydroxide, which is a alkali or base. It gives sodium sulfate plus ammonia. This is very much important, and liberation of water molecule. When ammonia is treated with again unused acid, that gives ammonium sulfate. Zedoll's method is not applicable for compounds containing nitrogen in the ring and compounds containing NO2 group. Means in the ring or NO2 group, whenever it is present, this method is not applicable. Okay. We'll see the procedure. Step 1. Conversion of nitrogen in the compound to ammonium sulfate. A sample of organic compound is weighed accurately and placed in the Zedoll's flask. Excess of concentrated sulfuric acid and potassium sulfate are added. A little of mercuric sulfate is added as a catalyst. The flask is heated until the solution becomes clear and then cooled. What they are telling, a sample of organic compound they have taken in a Zedoll's flask and they have heated with the concentrated sulfuric acid. The excess of concentrated H2SO4 they have added, and the potassium sulfate also they have added, and little bit of mercuric sulfate as a catalyst. Okay, 3 chemicals they have added in the flask and they have heated till the solution becomes clear and they have cooled. Next one, estimation of ammonia. The contents are transferred to a round bottom flask. A strong solution, that is 40% of sodium hydroxide is added. The apparatus is arranged as shown in the figure. The flask is heated. The ammonia liberated is passed through the condenser and absorbed in a known volume of standard acid taken in a conical flask. The unused acid is then titrated against standard alkali. We have seen this thing in the principal part itself, that whatever the contents used in the step 1, that is the conversion of nitrogen in the compound to ammonium sulfate, that overall part which has been cleared and cooled, that will be transferred into round bottom flask and that solution was treated with concentrated, that is 40% sodium hydroxide, and the flask is heated. The ammonia was liberated, passed through a condenser. That time ammonia will be starts liberating and they will move from the condenser. And they have observed that how much standard acid is taken in a conical flask. The unused was titrated against the alkali. See here Zedal's flask, this is here compound H2SO4, potassium sulfate, everything they have mixed here and they have kept for heating. Estimation of ammonia. The overall part has been taken here. Next is calculations. The mass of organic compound is W gram. Volume of the standard acid required to neutralize the ammonia is V cm cube, that is volume cm cube. Normality of the acid, and that is N, V into N. This V, that is volume of standard acid required to neutralize ammonia, into normality of acid. This is volume into, that is volume into normality of ammonia. 1000 cm cube of one normal ammonia contains 17 gram of ammonia, that is NH3. 14 into hydrogen, 3 hydrogens, that is 17 gram of ammonia. This is 1000 cm cube of one normal ammonia contains 14 gram of nitrogen. Therefore, volume of cm cube of nitrogen, normal ammonia contain V into N by 1000 into 14 gram of nitrogen will be equivalent to X gram of nitrogen. So, what will be the W gram of the organic compound contains X gram of nitrogen. Okay. 100 gram of the organic compound contain X by W into 100 of nitrogen. So, overall percentage of nitrogen in the compound, volume of acid in ml into normality of acid divided by mass of organic compound into 14 into 100 by 1000. This is the equation where you have to use for the estimation of nitrogen. We will see problem. 0.3465 of organic compound, digestion with the concentrated sulfuric acid and distillation with excess sodium hydroxide solution, liberated ammonia which was absorbed in the boric acid solution. It requires 42.80 centimeter cube decinormal hydrochloric acid for neutralization. Calculate the percentage of nitrogen in it. Solution. Volume of hydrochloric acid is 42.8, normality of hydrochloric acid 0.1, mass of the compound 0.3465, that will be converted into milligram. Percentage of nitrogen V into N into 14 by W into 100 by 1000, that is the percentage formula. 42.8 into 0.1 into 14 divided by the weight into 100 by 1000, you will get 17.3. This is about the estimation of nitrogen by Zedal's method. You should not forget the two various kinds of methods. One is Dumas method and Zedal's method for the estimation of nitrogen. Next one, the estimation of halogen, sulfur and phosphorus. For three of things, the Carius method will be used. Percentage of halogen, sulfur and phosphorus is determined by Carius methods as follows. In that, first one we will see halogens. To know of the organic compound, fuming nitric acid and silver nitrate solution are added and strongly heated in a Carius tube. The halogen present gets converted into corresponding silver halide. It is filtered, washed and weighed. See here, all three kinds of all the three kinds of elements like halogens, phosphorus and sulfur will be estimated by Carius method by Carius tube. This is the Carius tube. Inside that organic compound will be present. For that, fuming nitric acid, that is HNO3 and silver nitrate should be used and heated properly. After heating, the halogen whatever it is present, it will be get converted into corresponding silver halide. If it is in the organic compound iodide is present, silver iodide. If bromide is present, silver bromide. Like that it will be formed and it should be filtered, washed and weighed. This is a very simple experiment. This is a Carius tube. It should be sealed. We will see the calculations. Mass of organic compound milligram. Mass of this silver halide formed. that will be Wg. Molecular mass of silver halide will be M. Atomic mass of halogen will be X. Mg of silver halide contains X gram of halogen. See here, W gram of silver halide contains W into X by M, that is gram of halogen. So overall percentage of halogen is W into X by M into 100 by M, that is molecular mass. We'll see the problem now. In Carey's method, 0.11 gram of an organic compound gave 0.2500 gram of silver chloride. So calculate the percentage of chlorine in the compound. They have taken the organic compound in that much of weight. How much the halide has been given, the corresponding halide. The mass of organic compound is 0.1190. Mass of silver chloride 0.2500. Molecular mass of silver chloride 108 plus 35.5. Okay, overall this is silver chloride and this is chlorine 35.5. Overall 143.5. 143.5 gram of silver chloride contains 35.5 gram of chlorine. So overall whatever the silver chloride is formed, that much gram of silver chlorine contains 0.2500 into 35.5 divided by 143.5 gram of chlorine. So percentage of chlorine in the given compound, this much it has been formed. This is chlorine divided by this much you got into 100 into the overall given organic compound. We'll get 51.97%. This is about the halogens. What you have to understand, from the halogen, the corresponding silver halide will be formed. Next one, sulfur. A known mass of organic compound is oxidized to sulfuric acid by heating it with fuming nitric acid or sodium peroxide in Carey's tube. The acid formed is then treated with barium chloride solution. White precipitate of barium sulfate formed is filtered, washed and dried and weighed. Here a known mass of organic compound is taken in the Carey's tube and it has been oxidized to sulfuric acid by using nitric acid. The organic compound should be oxidized to sulfuric acid. Okay. For that, nitric acid should be used or sodium peroxide can also be used. The acid formed is then treated with barium chloride. Whatever the acid will be formed, that will be treated with barium chloride. That time barium sulfate will form as a white precipitate. That should be filtered, dried, weighed, everything. Sulfur plus nitric acid, that H2SO4 will form. That H2SO4 will be treated with barium chloride. Barium sulfate will be formed with the liberation of hydrochloric acid. From the weight of precipitate formed, the percentage of sulfur is estimated as follows. The calculations: mass of organic compound, mass of barium sulfate, molecular mass of barium sulfate is 233 gram, atomic mass of sulfur 32 gram, 233 gram of barium sulfate contains 32 gram of sulfur, 18 is the atomic mass of sulfur and W gram of barium sulfate contains 32 into W by 233 gram of sulfur. The percentage of sulfur in the given organic compound 32 into W by 233 into 100 by M. So overall problem, 0.35 gram of organic compound has been overheated with the fuming nitric acid and barium chloride. It gave 0.80 gram of barium sulfate. Calculate the mass and percentage of sulfur in the given compound. Mass of organic compound 0.35, mass of barium sulfate 0.80 gram. The overall 233 gram of barium sulfate contains 32 gram of sulfur. Okay. And here 0.80 gram of barium sulfate contains 32 into 0.80 by 233. It will get 0.1098 of sulfur. So overall percentage of sulfur, whatever you got, divided by how much the organic compound, overall organic compound weight into 100, it gives 31.37%. This is about the sulfur, the estimation of sulfur with its problem and calculations. Next one, phosphorus. A known mass of the organic compound is oxidized to phosphoric acid using fuming nitric acid. The acid formed on treatment with ammonia and ammonium molybdate gives a yellow precipitate of ammonium phosphomolybdate. It is filtered, washed and dried and weighed. A known mass of organic compound should be taken in a Carius tube and should be oxidized for phosphoric acid. The phosphorus will be oxidized for phosphoric acid by using HNO3, that is nitric acid, and it was treated with ammonia and ammonium molybdate, which gives a yellow precipitate of ammonium phosphomolybdate. It gives a yellow precipitate. It should be filtered, dried, weighed and washed. From the weight of the precipitate formed, the percentage of phosphorus is calculated as follows. See, the overall everything is same, the calculation. First, mass of organic compound, mass of ammonium phosphomolybdate. Molecular mass of ammonium phosphomolybdate is 1877 gram. Atomic mass of phosphorus is 31 gram. So, for that ammonium phosphomolybdate, the 31 gram of phosphorus will be present, that we know. For that, how much gram of phosphorus will be present? W into 31 by 1877. The percentage, weight taken by weight, already was weight of organic compound into the atomic mass into 100 by m. Okay. Phosphorus can be estimated by converting the phosphoric acid formed into magnesium pyrophosphate by heating it with magnesia mixture. This is the magnesia mixture, and igniting the magnesium ammonium phosphate precipitate formed. This is a little bit another form also. The whatever the phosphorus can be estimated. Okay. See, H3PO4 MgSO4, and this is ammonium hydroxide, ammonium chloride. This is the overall mixture, the magnesia mixture. Molecular mass of magnesium pyrophosphate is 222. If the phosphorus is estimated as the magnesium pyrophosphate, then the percentage of phosphorus is calculated using the formula 62 into W by 222 into 100 by M. There are two methods. One is using ammonium molybdate, another one is using magnesium pyrophosphate. That time you should change the molecular mass and the atomic mass of individual compound. Okay, this is about the phosphorus. Next one is estimation of oxygen. This is the extra information. Okay. Method, the percentage of oxygen 100 minus sum of percentages of all the other elements. Whatever the all other elements will be present in the compound, it should be percentage of oxygen by 100 minus the sum of percentages. Or the next method, in this method the given organic compound is pyrolyzed or decomposed by heating in a stream of nitrogen, and the gases formed are passed through red hot coke and carbon monoxide is formed. Carbon monoxide so formed is passed through warm iodine pentoxide to give carbon dioxide and iodine gas. One method is that one by minusing or by subtracting the sum of percentage of all the other elements, or the organic compound should be pyrolyzed. What is pyrolyzed? Nothing but decomposed by the heating. In the stream of nitrogen and the gaseous formed are passed through the red hot coke and the carbon monoxide. So, carbon monoxide so formed, whatever the carbon monoxide is formed, it should be warmed with iodine pentoxide to give carbon monoxide and iodine gas. So, how the organic compound heated, the oxygen will be formed, the other gaseous products. Or the oxygen is treated with red hot coke at 1373 Kelvin, it will form carbon monoxide. Okay, it is the redox reaction what they are doing into 5 carbon monoxide. This is iodine pentoxide at 448 Kelvin. Carbon monoxide and iodine gas will be formed. The overall reaction is 10 carbon plus 5O2 plus 2I2O5, that is iodine pentoxide. This is carbon monoxide and iodine gas. From the mass of carbon dioxide formed, the percentage of oxygen is calculated as follows. The overall thing is same, mass of organic compound, mass of carbon dioxide formed, 44 gram of carbon dioxide, that is atomic molecular mass of carbon dioxide. This is atomic mass of oxygen. Weight of carbon dioxide contains W gram, 16 into W by 44 gram of oxygen. this is how much of organic compound formed, 16 into W by 44 gram of oxygen. The overall 100 gram of organic compound contains 16 by 44 into W by M into 100. The percentage of oxygen is 16 into W by 44 into 100 by M. This is the overall calculative part of the estimation of oxygen. So, we will see one of the problem. Calculate the percentage of oxygen present in 8 gram of an organic compound which gave 10.10 gram of carbon dioxide when the carbon monoxide formed on heating the organic compound with red hot coke passed through iodine pentoxide. The given data you have to first write mass of organic compound, mass of carbon dioxide formed. So, this is one line you have to write everywhere, like how much the carbon dioxide, the molecular mass of carbon dioxide, and what is the atomic mass of individual element which has to be estimated. And this much of carbon dioxide contains 10.10 into 116 divided by 44 gram of oxygen. So, percentage of oxygen will be into 16 by 44 into 100 by M, that is 8 equals 45.90%. So, overall this is about the estimation of oxygen. Okay. So, all the elements, whatever major elements are present and whatever the elements are given in your syllabus that has with respect to estimation we have done or we have discussed today. So, completely all the elements with the estimation part and the calculation part we have discussed today. So, this completes your organic chemistry, the first chapter, some basic principles and techniques. So, I hope you have understood completely what I have taught today. Thank you.